Want to learn Spring Boot fast? Great, you're in the right place. In this Spring Boot course, you'll learn how to create a REST API with Spring Boot from start to finish. Not just coding, but from project setup through to deployment. Follow along for a brief description of all the modules in this course and the content of each module. These are the modules: project setup, design, implementation with unit testing and integration testing, and deployment. Let's take a closer look at each module. Project setup. So here I show you two different methods of setting up the project. You could choose to use either one depending on your preference. Lesson 1. Set up the project using Spring Initializr. In this lesson, we look at how to use the Spring Initializr to create a project, Spring Starter dependencies, and then the generated build file. Lesson 2. Set up the project using Gradle without Spring Initializr. In this lesson, we generate a Java project using Gradle command line. Then work on the build file to add the required plugins and dependencies. Discuss core Gradle plugins, community plugins, and the Gradle plugins portal. And then we generate the Eclipse configuration files to import the project to Eclipse. The next module is design. This module is consolidated into one lesson. In this entire course, we are creating a REST API which would save, retrieve, and delete comments of blog posts. So in this design lesson, we discuss what is REST, some basic REST API design principles, and then design the comments API, and also we look at the application architecture of a Spring Boot project. The next module is testing and implementation. This module consists of several lessons on unit testing, implementation, and also integration testing, the API. The first lesson of testing and implementation. Endpoint implementation to retrieve comments, part 1, which is the implementation of the controller. In this lesson, we implement a method to return all comments of a particular post in a test-first manner. That means, as in all of the implementations throughout the project, we write unit tests before writing a single line of logic. The next module is deployment. Here we look at various ways of running the application, and then war deployments to an external server. And then we connect our application to MySQL Server instead of the embedded database. And then we look at how to use the embedded database for integration testing while using an external database for production. Let's take a look at project setup. That is mainly creating the build file. Oftentimes, dependencies could be tricky. There are so many external libraries, and selecting versions that should be compatible with each other can be difficult at times. But there's a one-stop shop for all the dependency requirements of a Spring Boot project. That's the Spring Boot starters. All you have to do is select a few starter dependencies according to the type of the project, and the starter dependencies will take care of the rest. There's a list of all the starters available in the Spring Boot documentation, with a brief description and a link to the POM. So, if you're building a REST API or a web project, you would add the Spring Boot Starter Web dependency to your project, and if you take a look at the POM, you can see all the other dependencies that it includes. If you want to use Spring Data JPA, you would add the Spring Boot Starter Data JPA dependency. Creating the build file. You can do this in a couple of ways. The easiest is to use the Spring Initializr. Go to start.spring.io and add the Spring Boot starter dependencies that you want, Web, JPA, and H2 for this project, and generate the project. Simple, but let's see how to do it. This is the Spring Initializr website. Here you can select the build tool you want to use. I'm using Gradle, so I'll select that. Then the programming language. Java is selected by default. And then the Spring Boot version. And this is selected by default. You could add the project metadata here, but I'm going to keep this as it is. I can change these later. You could select a specific Java version if you want to. Java 8 is selected by default. Now the dependencies are selected in here. Once you start typing, a list of matching dependencies will pop up down here. For example, if I want to create a REST API, I'll just type REST here and have a look at the suggestions that pop up. So This first one says build web including RESTful applications using Spring MVC, uses Apache Tomcat as the default embedded container. So this is exactly what I want. If I click on this or press enter, it'll be added to my project. If I want to remove it, I'll just have to click on it and it'll be removed from the project. I'll just add that back in. So I'm going to add JPA and H2 and then click on the generate project to download the zip file. Now let's take a look at the generated project. The folder structure is created and there's a sample application file as well. If you look at the build file, there are some plugins applied. There's a Spring Boot plugin, the Spring Dependency Management plugin, and the Java plugin. The Spring Boot plugin adds Spring-related functionality such as boot jar or boot war, basically enabling us to package the project to an executable jar or war file. Boot run allows us to run the application using Gradle without having to package it. Also, if you notice down here in the dependencies section, there are no versions mentioned for any of the dependencies. That's because when using the Spring Boot Gradle plugin, the versions are handled by the plugin. We don't need to provide it. Then here's the Spring Dependency Management plugin for Gradle. This adds some of the Maven-like dependency management capabilities to Gradle. For example, there are some exclusions declared in the POMs of some Spring dependencies, but Gradle does not work accordingly. This plugin makes Gradle honor the exclusions declared in Maven POMs. This Java plugin adds Java-related capabilities to the project such as compilation, testing, and packaging. I also want to add the Eclipse plugin here just so we can generate the necessary Eclipse configuration files in order to import this project into Eclipse. Then there's the group ID and the version. I'll change this to com.comment. The source compatibility. So this is a way to declare which version of Java your source code is compatible with. For this project, it is 1.8 because from Spring Boot version 2 upwards, the minimum supported Java version is 8. It does not support Java 7. This is the repositories section using Maven Central. You could change this to use JCenter instead, but it doesn't really matter. Now at the bottom is the dependencies section. The Spring Boot Starter Data JPA and the Spring Boot Starter Web are added as implementation dependencies. Then there is a runtime only dependency which is H2. There's one test implementation dependency which we did not select but has been added by the Spring Initializer. Another way of setting up the project is to use Gradle command line to generate a project and add each of the dependencies to the build file. So if for some reason you decide not to use the dead simple Spring Initializer, here's how to set up the project manually using Gradle. I've opened up a terminal, creating a folder for the project, and cd into it. And I'll create the Gradle init task with the type Java library. Init is a task of the build init plugin. You can read more about it in the Gradle documentation. Basically, it can be used to create a project by providing the specific type of project to generate. It currently supports a few types such as Java library, Java application, Scala library, etc. I'm using Java library here, but you could use Java application as well. And it doesn't make any difference for this project because I'll change the build file to my requirement later. Done. And let's look at the generated project. Here's the folder structure created and the build file. I'll remove some of the comments here to make it more clearer. Now we have to do a bit of work here to make this a Spring Boot build file. First, let's look at the plugins. There's a Java library plugin added here in the plugins section, but instead of the Java library plugin, what I want is the simple Java plugin. So I'll remove this and add the Java plugin. And then I'll add the Eclipse plugin as well. This Eclipse plugin will allow me to generate the Eclipse configuration files so that I can import this project into Eclipse. If you are using IntelliJ, you would want to add that plugin here instead of the Eclipse. I think it's called IDEA. This Java and Eclipse plugins are core Gradle plugins, and they come with the Gradle distribution. So I only provide the simple name, which is Java or Eclipse, to add them. But if you want to add a community plugin which does not come with the Gradle distribution, you should provide the fully qualified name and the version. Since these plugins aren't available in Gradle distribution, there should be a way to resolve the plugin. Or in other words, we should tell Gradle how to find the plugin jar file before it can be applied. If the plugin is available in the plugins portal, Gradle will download and use the plugin from the portal. Let's see how to do this. This project needs two plugins which are not core Gradle plugins, the Spring Boot plugin and the Spring Dependency Management plugin. So let's look them up in the Gradle plugins portal. First, I'll look for the Spring Boot plugin. Here it is. So I need to grab the ID of the plugin, which is org Spring Framework Boot. And then I also need the version, which is 2.1.8. Now search for the Spring Dependency plugin. The ID is io.spring.dependencymanagement and the version is 1.0.8. And then I'll add the group ID and the source compatibility, and then add the Spring Boot starter dependencies here in the dependencies section. So that's all there is to be done here. The next step is to generate the Eclipse files and import this into Eclipse. I have opened up a terminal and then cd into the project folder. Now I'm going to use the Eclipse plugin that I added in the build file. /gradlew Eclipse. Eclipse is a task of the Eclipse plugin which generates all Eclipse configuration files. That's complete. So if you look at the project folder, all the config files are present. Now in Eclipse, I'll right-click on the Project Explorer and select Import. And then under the General section, select Existing Projects into Workspace. Now browse into the project folder. So here you can see that the project folder has been identified as an Eclipse project. Click Finish. Great, here's the project imported in Eclipse. Design. Before we dig into the design of our REST API, I would like to discuss some of the basic but often overlooked REST API design principles. Let's go through each of them quickly. REST stands for Representational State Transfer, and this is how it's explained in Wikipedia. REST-compliant web services allow the requesting systems to access and manipulate textual representations of web resources by using a uniform and predefined set of stateless operations. Simplifying further, a REST API communicates with clients in terms of resources on which a client could perform operations such as read or retrieve, create, update, and delete. So, the basic principle number 1 is resources are nouns. A resource could be anything that we expose to our client through the REST API. Some examples are customer, product, quote, price, order, comment. These are all nouns, obviously, but it is important to remember that when designing the URLs, which we'll see in a moment. Here are some examples of resource URLs. Example.com/products, stackoverflow.com/questions. This is a real one. What we don't want to do with URLs is to add verbs in front of the resource, such as example.com get products or stackoverflow.com/list questions. This is not how REST-compliant URLs are built. Basic principle number 2. Always use plural nouns for resources in URL. The same examples we saw earlier. Use products, questions, not product or question. Basic principle number 3. Use HTTP methods appropriately. A REST-compliant web service has a predefined set of stateless operations, and those are the HTTP methods. Use GET for retrieving, POST for creating, PUT for updating, and DELETE for deleting a resource. These are the verbs that applies to a resource. Basic principle number 4. Appropriate use of HTTP status codes. Some common codes are 200 meaning just OK, 201 for created, 204 no content. This could be used for a delete. All 200 codes mean request was processed without any issues. 400 codes means some client error, such as 400 is bad request, 401 is unauthorized, 404 a very common one which is not found. Last but not least, HETEOS, which stands for Hypermedia as the engine of application, simply means to use links for navigating the API. Comments API design. If the resource was independent, the URLs would look like this. Get method for /comments would return a list of all comments. /comments/id, which is the comment ID, would return a particular comment. POST/comments would create a comment. PUT/comments/id would update a particular comment. DELETE/comments/id would delete a comment. But in this case, comment is more of a sub-resource because a comment always belongs to a post. You can handle this in different ways, but it is a matter of personal preference, or if you're working in a team, you could discuss and decide which approach to use. So this is how I designed the URLs. Get and post URLs would be posts/id, which is the ID of the comment, and then /comments. I'm not allowing comments to be edited, so put will not be used. Delete would be /comments/id, which is the ID of the comment. Application design. The application code is organized in 3 layers: repository, service, and controller. The controller layer holds the API classes, which would serve the incoming requests. The service layer is where the business logic is happening. The controller will delegate all the business logic to the service layer. The repository layer is for exchanging data with the database. That means it consists of all the repository interfaces which the service classes would use to access the database.
Let's move on to testing and implementation. Now, I would like to refer back to this high-level architecture of the project before I start. I'm going to start with the API, which is the controller layer. Here, we need a resource controller class to handle the incoming HTTP requests, which I would call comment controller. So let's start with that. The comment controller would handle the get, post, and delete requests for these URLs. In order to serve this GET request, the controller should return a list of comment resources. So we can write a test for this behavior.
What I'm going to do here is test first development. So that means before writing any implementation code, I'm going to write a test. I don't have anything in the src main Java folder, source folder, and there's the src test Java folder, and I'm going to create a new JUnit test in it. Right click on that and select new, other, and then in here there's a Java folder. Expand that, and under that there's a JUnit folder, and in there's a JUnit test case. I'm going to select that and click next. And then in here, the new JUnit 4 test has already been selected for us, and the source folder is correct. And then the package, I'm going to place this test in a package called com.comment.controller. So the name of this test, since I'm writing this test to test the comment controller, I will name this test class comment controller test. So basically this is the name of the class under test, and I just add test at the end. I want the setup method to be generated by Eclipse. That would be easy. So we don't have a class under test yet, so I don't need to add anything there. And I'll click finish. So here's the test class generated by Eclipse, and there's the setup method, and then there's a sample test. So I'm going to remove this line. So the very first test that I'm going to write in this comment controller test is to test whether the comment controller would return a list of comments for us. So this is how I'm going to name my tests. Of course, test, and then name of the method under test, which would be get comments by post ID, and then the expected result returns a list of comments. I'll start with an assert. There's actual and there's matcher. So for the actual, I need to provide the return value of the actual method call. So what I'm going to do here is create an object here for the actual method call, comment controller, and the method is get comments by post ID, and of course we need to pass in a post ID, so I'll pass in 1 here. So if this is a list of comments, we should be able to check whether it's empty. So on this I'll call is empty method, and this method is a ham crest matcher, so I'll need to import that. I'll add a static import here, and I'm going to import all the matches. And now this comment controller object, we have to create it. Place the cursor there. Command 1 or control 1 would bring up this pop-up with all the suggestions. So what I want to do is create a local variable, and this local variable should be of type comment controller. Now I have to create this comment controller class. So create class comment controller, and this new class should be placed in the src main Java source folder. So I have to change that from test to main. And then the package is com.comment.controller. That's fine. So everything else looks good. Click finish. Now that's been created, and so there should be this method in that class as well. Make Eclipse generate that one for me as well. Create method, get comments by post ID. So that has been created. So there's a compiler error on this isEmpty method because we're not returning a list. So I'll make this return a list, and this list should be of type comment. And we haven't created this comment type, so I'll need to create that one as well. Not import, but create class comment. So the source folder is fine and all good. Click finish. So that has been created, and then we need to initialize this object. So now all the compiler errors are gone. I'll just quickly run this test to see how it goes. So there's a null pointer exception because we're returning null here. So to quickly get the green light, I'm going to return a list from here. arrays.asList. Now here I can provide as many objects as I want. So I'm passing in a couple of comment objects and converting it to a list to return. And now if I run this test, it should pass. So this test is passing. So I'm going to write another test to test if this method returns the list of comments which all have the same post ID as the one that we pass into the method. I'm going to copy this first part of the test method declaration. So the next part of the method name is all comments belong to the same post. And again, I'm going to start with an assert. So for the actual method call, we're going to need this object. So what I'm going to do here is, instead of duplicating this inside of this method, I'm going to make this a field and then initialize it in the setup method so that it can be used in all of the tests. So comment controller dot get comments by post ID, and I'm passing in 1 as the post ID. And for the matcher, I'm going to use every item matcher from the Handcrest matches, which analyzes each and every item of the list. And inside of here, I want to check whether it has the property post ID and then compare it with the value that we pass in. So has property should do. So name should be a string, post ID, and then value is 1. And I will extract this into a local variable. Now I'm all ready to run these tests. Ideally it should fail because we haven't done anything in the implementation yet. So first one still passes, and the second one is an assertion error. Expected every item is has property post ID is 1, but it doesn't have the property, no property post ID. So what we're going to do now is, so I'm going to move this into a different package because this is not a controller. This is more of an entity, so I'll move this into an entity package. And now I'm going to add this property post ID in here. So the post ID should be an integer. And I'm going to generate getters and setters for this. Okay, and then run the test again. Again, it should fail because the post ID was 0. So now we have to pass in a list of comments for the comment controller to sort through and send us back in this method. And how I'm going to do this is to pass in the list of comments when creating the comment controller object. I'll just create the list over here first. And then I'm going to create this constructor in the comment controller class. So create constructor. So I'm going to create a field. Instead of this list that we created on the fly, I'm going to return this one. Then I'm going to add some comment objects to this list. And also I want to pass in a post ID whenever this comment is created. So I'll just pass in 1 and create that construct inside of the comment class. So all that's done. I'll duplicate this. And now we have 2, 3, again 1, again 2. So we have a few comments, and we'll run this again just to make sure. It still gives the assertion error. Every item has property post ID 1, but an item property post ID was 2. So instead of filtering it, it's just returning everything. So I'm going to use a stream to filter. So post ID should be equal to the post ID parameter, and then collect this to a list. So I'll run this test again, and now both tests are passing. I want this method to throw an exception if the post ID is invalid. So this method name has 3 parts to it instead of the 2 that we saw earlier. This is the method under test, and this is the expected outcome, and this is the condition. Expected exception. So what I'm expecting this to throw is an invalid parameter exception. So now I'm going to create this exception class. And it should be in the main folder, package com.comment.exception. And then I want it to extend from the runtime exception. And click finish. So now I have this exception class created. I can go ahead with the method call. Just copy from over there. And I want to pass in an invalid post ID, which I say is -1. I'll just add a comment here just to say what is a valid post ID. So any positive integer is considered a valid post ID. Integer, let's say greater than 0. So I want to check both -1 and 0. So I'll run all of the tests. So expected exception is not thrown, and I'm going to add the validation here. Now I have a typo in the name of the exception class, so I'm going to correct that right now. And so that's done. Let's run this again. So we have 3 passing tests. Now I want to check if this method returns all of the comments that belong to the post ID. So for example, I have 1 and 2 comments with post ID 1, and then I'm going to add another one and maybe another one here. So there's 1, 2, 3, 4. 4 comments with post ID set to 1. So I'm going to test that one as well. So I'm just gonna copy this test over here, and I want to check the size of the list, and it should be 4. So this returns all the comments that belong to the same post. And then again, I want this to return an empty list when there is no comment with the given post ID. So again, I can copy this one. Empty list when no comments for the post. So say 100. So in this case, is empty should be true. This should pass without any change in the implementation. So now that I have the basic requirements covered for the controller, I'm gonna look inside the controller class with comments by post ID method and see if it needs any refactoring. So of course I can see that there is a bit of business logic happening in here, which is filtering. Looking back at the high-level design, we can see that the service layer is where the business logic should be. So I'm going to delegate the filtering logic to the service layer. For that, I'm going to create a comment service class, and this should have the functionality to filter the list of comments to find only the ones which has the given post ID, and then it should return all of the comments which belong to that particular post. Now the commit controller class will call a method on the commit service to get the filtered comments, and of course passing the post ID as a parameter. So now I'm going to create a new test for the service class. It should be in the com.comment.service package, and the name comment service test. So just as with the comment controller test, I'm going to assert that the comment service class would return a list of comments for a given post ID. So this comment service object should be of type comment service. And now I'm going to create this class. It should be placed under the src main Java source folder. And the package is correct, com.comment.service. And click finish. So here's the comment service class. And now creating the method. Now I can run this test. So we're getting a null pointer exception because we're returning null here. So what I'm going to do now is return a list of comments here, just so we get the green light. So I've run the test again and now it passes. So now that I have this method implemented in the comment service class, I want to make sure the comment controller delegates the business logic to the comment service class. So for that, we will have to add a dependency of the comment service inside of here. So I'll import the comment service and create getters and setters for this one. So before doing any more changes inside the comment controller, I want to make sure that I haven't broken any tests in the comment controller test. So I'll run these tests again. All 4 tests are still passing. So what I'm going to do now is make sure this dependency gets injected into the into this object while it is created. So I'm going to create the comment service field here. So I'm not going to pass in the real object. Instead, I'm going to use Mockito. And Mockito will create a mock object of this class and inject it into the comment controller. So to do that, I'm going to add the add mock annotation on top of this comment service, which I want to be a mock. And then this is our class under test. So on top of that, I want to add inject mocks annotation. So now I'm not going to create it inside here. So instead of initializing it myself, I'm going to tell Mockito to initialize the variable with all the dependencies. So this is how you do it. Mockito annotations dot init mocks, and this you pass in this, which is the object of this comment controller test. So when you add this line, this object will be created with all the mocks injected into it. And now I want to run these tests again to see what has been broken. So as you can see, 3 tests are failing due to a null pointer exception. If you look at the code, this comments object is null. We're not using this constructor anymore. And we're not passing in this list of comments to this one. So I'm going to remove these 2 and use the comment service to retrieve the list of comments. So get comments by post ID, and of course we need to pass in the post ID. So if I run this test again, let's see how many of them are passing. So now we've got 2 tests passing and 2 are failing due to assertion errors. So first one is expected is 4 but was 0. So let's look at this test. Return all of the comments that belong to the same post. So I'm passing in post ID 1 and I'm expecting a list of 4 comments. And then the other one, this test checks whether this method returns a list of comments, and expected false but was true. The list that the comment service returns is empty. So in here, what I would do is tell this mock to return this list whenever this method is called. So this is how I do it. When so I need to add the imports. So then return this list. So I'll make this a field. And I'll run this test again. So now that one is passing, and so now I want to fix this one, which is returns all of the comments that belong to the same post. So actually now this logic does not belong in the comment controller. And so I don't want this test inside of the comment controller test. So I'm going to move it into the comment service test. So I'll just add it in here and I'll work on that later. And I'll run all of these again. So now I want to make sure that this method is called from inside of the comment controller. So for that, I'm going to write another test. And I'm just gonna call this method under test and then use Mockito verify. to verify that the mock has been called. So we pass in the mock and times. So I want this to be called just once. I want this method to be called with the same parameter. So I'm going to extract this. And again, I will run all the tests. So now all of them are passing. So now I can move on to the command service test. So we moved this test from command controller test to command service test because the command controller is not doing any processing of the data anymore. It's just delegating to the command service. So I'm going to incorporate this test into the command service test. But before moving on, I would like to look back at the basic design of this application once again. The service layer in the middle, of course, holds the business logic, and it is also required to communicate with the repository layer to fulfill any data needs as well. The repository layer of the application will in turn communicate with the database. Let's take a quick look at the repository layer as well. In a typical application, the repository layer is where we write all the data access objects. But in here, I'm using Spring Data. So when using Spring Data, there's no need to write data access objects. You can use any JPA provider. You also get automatic custom queries and manual custom queries, which I'll explain later. This is how it all works. There's a commit class in the application. There's a commit table in the database. Spring Data is going to do all the hard work getting the commit back and forth. So what I'm going to do is create the commit repository interface, extending the CRUD repository interface, which provides some basic CRUD operations. CRUD stands for create, read, update, delete. These are the methods of the CRUD repository interface. For now, I'll use the findAll method to retrieve all the comments in the repository and then filter by post ID in the service layer. Later on, I'll use an automatic custom query in the repository to do that as well. Now, coming back to the commit service test. I want to provide the commit repository dependency into the commit service object when it is created. So I'm going to provide it as a mock inside of the test class. So now I'm going to create this commit repository interface. Create interface commit repository. I'll select that. And I want it in the src main Java source folder. So the package, I'm going to change this bit to repository. And I want to extend this from the CRUD repository interface from Spring. Now, this CRUD repository is a generic interface which requires two generic types. So first one is the type which we are writing this repository for, which is the comment. So I'm going to provide that type here. Then this ID is the type of the primary key of this comment. So we don't have a primary key yet, so I'm going to add one. So I've added a primary key which is of type int. So I'm going to add integer here. So I'm going to add the @mock annotation on top of this. So, and then here inject mocks. And what I'm going to do here is Mockito annotations, init mocks, this. So when we add this line, it will initialize this class under test with the dependencies that are marked with @mock annotation. So now that I've set up the comment repository mock, what I'm going to do is run these tests again. I'm getting the same results. So in order to fix this test, what I'm going to do is, first of all, I should provide this comment repository dependency into this comment service class, and then use that comment repository to return the list of comments instead of creating it in here. So now that I have the comment repository in here, I'm going to use that to find all the comments that are there in the database. So if you look at this method, find all, the return type is an iterable. So instead of an iterable, what I want is a stream. There are a few other things that I could do. I could simply override this method inside of the comment repository to provide me a stream or a list or whatever I want. But here I'm going to use the stream support from Java 8 to create a stream with this iterable. So I don't want a parallel stream. I'm going to provide false here. So this is going to give me the stream of comments. I'm going to sort it through and send the ones which has the same post ID as this one. So I'm going to rename this. I'm going to filter all the comments. The post ID should be equal to this post ID parameter, and then I'm going to collect this into a list. So this part is done, and it's still not going to fix this test, but I'm going to run it anyway. So now both tests are failing. So let me first fix the first one. Get comments by post ID. So we want a list which is not empty. So we should tell this comment repository to return a list of comments when the find all method has been called on that. So I'm going to use when from Mockito. I'm actually going to copy this list over here. So I will create a field called comments for this list of comments. And inside of this method, I'm going to initialize it and then add some values to it and return. So I'm telling the comment repository to return this list of comments when the find all method has been called on that. So if I run this again, now we have that test passing, and the second one, I'm going to use the same list. So now we have the same list, and the test goes like this. The post ID is 1, and we're expecting a list of 4 comments. So there should be 4 comments with the post ID set to 1. So we have 1, 2, 3, and 4. That's done, and I'm going to run this again. So both tests are now passed. So now that we have all the tests passing, it's time for some refactoring. I want to move all these filtering logic to the database. That is, I want to send a query like this. I want the database to filter the comments by post ID before returning it to the application. So something like select all from comment where the post ID equals the one we provide. So since we're using Spring Data, it's going to be really easy to do. We just have to write the method declaration, and I call it an automatic custom query. So again, these are all the methods that are available to use from the CRUD repository. I have used findAll, but wouldn't it be great if there was a method here to find by post ID as well? Well, even though there isn't such a method in this interface, it doesn't mean that we have to write an implementation for such a method if we wanted it. This is one of the coolest features of Spring Data. You can actually get away with just the method declaration in your repository interface. That's what I called an automatic custom query. There is a specific naming strategy for the method name though, so that the framework can build the correct query. If I wanted to find all the comments which has a particular post ID, I would name the method findByPostID and pass in the post ID as a parameter. Simple as that. Now what I meant by manual custom query is actually the ability to write a named query by using the @query annotation. So here is an example. So before moving on, I just want you to notice that we are extending from the CRUD repository, and if you take a look at the type hierarchy, there is our comment repository that we created, and then there is paging and sorting repository. So instead of the iterable that we got for findAll in the CRUD repository, if you use paging and sorting repository, it has these two methods overridden, and then there is a JPA repository which you can use, and it returns a list instead of an iterable for the findAll methods. So you can use paging and sorting repository or JPA repository depending on your requirement instead of this CRUD repository to extend your repository from. So back to the comment service test. What I'm going to do here is, instead of using the findAll method, I'm going to use findAll by post ID. And I'm going to pass in a post ID. In this case, it's 1, so I'll provide 1 here as well. And now we haven't added this method to our interface yet, so I'll quickly add that one. So create a method, and I want this method to return a stream of comments. So now coming back to the test, the return value from this method findAll by post ID is a stream. So we need to provide a stream here. So I'm going to get a stream from this list and return that. So now I'm going to run this test. So now that test is passing, and on to the next one. This method was initially written to test whether this getCommentsByPostID method would filter the comments given by the repository by post ID. But now that we have moved the filtering logic into the repository or the database, we don't need this test anymore. So I'm going to remove this. But I'm going to add a new test which will verify that this find all by post ID method from the commit repository will be called by this get comments by post ID method. So I've named this test method test get comments by post ID, calls repository to fetch comments. So that's exactly what we're going to test here. And I'm going to copy this bit because this is the actual method call. And I will just pass in one, or maybe, okay, I'm gonna create this local variable. And set it to 1. Then I'm going to use verify from Mockito, and I'm going to now give the mock object here, which is the comment repository, and then I can define how many times this should be called. It's just once, and then I want to verify that this find all by post ID method has been called with the post ID parameter. So now let's run the tests. Okay, now we have this get comments by post ID method and get comments by post ID calls repository to fetch comments. Both methods are passing. Now I want to clean up this test a little bit because this is a very simple test, get comments by post ID, and it should return a list which is not empty. That's all that we are testing, so we don't need all these different post IDs in comments. So I'm going to remove this because sometime later if I look at this test I should be able to understand this without any trouble or confusion about why we have all those post IDs. So this is what the repository will return, and then in turn will be returned by the get comments by post ID method. So I'll run these tests again. Okay, good. Now that I have implemented a part of the API across all 3 layers, it's time to write an integration test. For the integration test, I want to send a GET request to the API, and it should go through all 3 layers and come back with a response. And this response will be asserted according to the expectations of the API. There are a couple of approaches to this. One is to start a server and send the request using the test REST template provided by Spring. The other one is not to start the server at all, so Spring will handle the HTTP request and pass it on to the controller. The code will be executed exactly the same way as if it was processing a real HTTP request, but without the cost of having to start a server. So this is the approach that I'm going to use in my integration tests. For this, I need the support of the mock-MVC. So using the mock-MVC class, I can perform get, post, and delete operations. This perform method will return a result in the form of a result action on which I can perform further operations such as undo and return and expect. Now let's write some integration tests. I like to keep my integration tests separate from the unit tests, so I'll create a new source folder for that. New source folder. src integration test and Java. So now I'm going to create a new JUnit test, same as with the unit tests. What makes this an integration test is a few additional things like annotations and how we write the test. So new other JUnit test. So same as with the unit test, new JUnit 4 test, and the source folder, then the package. I would have this in the com.comment package, and I'll name this integration test comment API test. So click finish. So before starting, I want you to notice that in any of the implementations that I've done so far, I haven't added anything specific to Spring Boot. It is just plain Java code. We don't have any annotations or anything. So at this point, I want to start adding in the annotations as and when I see they're needed to make this a Spring Boot application. The reason I like to build up the application this way rather than setting everything up at the beginning is because now I only add what I need. If you do it up front, you might be left with bits and pieces which are totally useless to the application at the end. I'm going to add a couple of annotations to this class now. First is the run with annotation. This annotation makes JUnit use the Spring Runner class to run the unit tests in place of the standard JUnit test runner. So we get the Spring's testing support for this test. Next is the Spring Boot test annotation. This annotation tells Spring Runner to start the test as a Spring Boot application, scanning for Spring components and configurations like REST controller and configuration annotated classes, and using the application YAML file to initialize the environment. So as mentioned earlier, I want to send a GET request to my API, which has this URL, and for the very first test, I want to test whether it returns status 200, which is an OK from the API. So in order to send a GET request, I'm going to need the mock MVC. So for that, I'm going to inject it to my test class, and I'm going to name it just MVC. So I have the mock MVC, and for this to work, I need to add another annotation here, which is auto configure mock MVC. Quite self-explanatory. It configures this mock MVC without us having to do anything else. So this annotation lets us use the mock MVC in our test class. So let's see what this can do. So the method that I'm going to use is perform mvc.perform, and I have to provide a request builder. So as a request builder, I'm going to use the mock MVC request builder, which I'm going to import over here. So for the request, there is mock MVC request builders. That's what we want, and I'll import that. So that will give me this method get, and I need to pass in the URI, which is post/1/comment. So this is the post ID that I'm sending, and so this is the URI. And now there are some methods which we can perform on the results that we get from this perform method. So if you look at the perform method, it returns a result action. So this allows applying actions such as expectations on the result of an executed request. So these are the methods that are available to us, and do and expect and return. So I'm going to choose this one and expect. So what I'm going to expect here is the status status should be okay. So there's a status method which we can use in mock MVC request matcher class. So I'm going to import that. So that is in the org Spring Framework test web servlet result mock MVC result matches. So now we can use this method to check whether the status is okay. So there are a whole lot of statuses in here which we can compare the results with. So this method throws an exception, that throws declaration. That's what I'm going to do. And I'm going to rename this method comment API get comments by post ID status okay. So now we have all of this, we can run this test. But we don't have a Spring application yet. All we have is a bunch of Java classes. In order to make this a Spring application, we have to write some more application code. But let me run this test anyway. Let's see what comes up. So it tries to start the application, but there's an initialization error. It's unable to start the application as a Spring Boot application. So basically, we need to make this a Spring Boot application by creating an application class and annotating it with at Spring Boot application annotation. So let's do the groundwork first and then come back to this test. Let's see how to make this a Spring Boot application. Following is the very minimum you have to do to make this, or in fact any Java application, a Spring Boot application. First, create a main class extending from the Spring Boot Servlet Initializer class. Then add the Spring Boot application annotation to that class. Finally, add the main method. Now let's look at each step in detail. First, create a main class. You can give any name to it, so I'll name it Command Application. This main class should be placed in the root package. And this allows for component scan to apply on the whole project. So the package structure of this project looks like this at the moment. There is com.command.controller package where I have the command controller class, and then the com.command.entity package which has the command class, and it goes on like this. So the root package is com.command, and this is where I want to place the main class in. Next, adding the Spring Boot application annotation. This is a convenience annotation that is equivalent to declaring these three annotations: enable auto configuration, component scan, and add configuration. So what do they do? First, let's look at enable auto configuration annotation. As the name suggests, this enables the auto configuration of the Spring application context, attempting to guess and configure beans that you're likely to need. If you have worked with a typical Spring application, you should be familiar with all the configurations that are needed, such as data sources, entity manager factories, dispatcher servlets, and the list goes on. By enabling auto configuration, the Spring Boot framework kind of looks at the jar dependencies that you have added to the application and the existing configurations for the application if there is any, and then based on these automatically configures your Spring application. For example, if you have H2 on your class path and you have not manually configured any database connection beans, then Spring Boot auto-configures an in-memory database. How convenient is that? Next, component scan annotation. This is the annotation which we can use to tell the Spring framework where to scan for beans. That is basically the classes annotated with @component, @service, or @repository. So when this annotation is on a particular class, the package of that class and all of its sub-packages will be scanned for beans. That's why we want to place the main class in the root package so that all the beans could be found. Last one is the configuration annotation. This basically allows to register extra beans in the context. Spring Boot favors Java-based configuration, and in the documentation it is said that although it is possible to use Spring application with XML sources, we generally recommend that your primary source be a single configuration class. Usually the class that defines the main method is a good candidate as the primary configuration. So I guess that explains why it is bundled in the Spring Boot application annotation. So now we've annotated the main class with the Spring Boot application annotation, it is time to add the main method. And in the main method, we delegate to the static run method of the Spring application class, providing the main class and the args as parameters to launch the application. Now I'm going to create the main class. In the com.command package, which is the root package. Command application is the name of the class. It should extend from the Spring Boot Servlet Initializer class, so I'm adding that here as the superclass. I'm also going to tick this box, which will generate the main class for me. All done, click Finish. Adding the Spring Boot application annotation to this class. Now I'm calling the static run method of the Spring application class, passing in the main class and args. Now I'm going to run this as a Java application to see if it will launch as a Spring Boot application. Well, as you can see, now there is an illegal argument exception, and it says comment is not a managed type. So now I have to mark comment as an entity. But why would Spring Boot complain about the comment class? It is just a plain Java class. Well, I have mentioned the comment class in the comment repository, which extends from CRUD repository. That's the reason why it complains. So of the two generic types of the CRUD repository, first one should be an entity, and the second one should be the type of the primary key of that entity. So the comment class should be annotated with @entity annotation. Now, because I have enabled auto-configuration at the root package, all the sub-packages will be scanned for entities. Otherwise, I'd have to use the entity scan annotation to tell Spring Boot where to find the entities. I'll run the application again. Now there's another problem. No identifier specified for entity comment. Now I have to annotate the primary key of the comment with @id annotation so that it's recognized as the primary key. And run it once again. Now that it's started successfully, I'll get back to the integration test. I've fixed some typos here if you've noticed. Organize imports. And now I'm going to run this as a JUnit test. Okay, here we have the results. It has failed. A session error says the status expected 200 but was 404, which means the requested result was not found. So how do we go about this? HTTP status code 404 means not found. What was not found? Of course, the resource. What resource was requested? Well, comment is the resource that was requested. So we have a class to represent the resource, which is comment. And in order to serve the resource, the comment controller class was created. In Spring's approach to building RESTful web services, HTTP requests are handled by a controller. But then how is this controller identified by the framework? Annotations, of course. That means it's time that I add the appropriate annotations to the comment controller. So now when I add the REST controller annotation to this class, Spring Boot will pick it up as a resource controller to serve the incoming HTTP requests. Again, REST controller is a convenience annotation that is itself annotated with @controller and @response_body. Response body annotation indicates that a method's return value will be sent in the response body. Because this is at the class level, it applies to every method in the controller. Now, the framework should know which method to be called depending on the HTTP method and the URI of the request. So for that, there are a few annotations that can be used. There is request mapping annotation, which can be used on both class level and method level. Then there are the HTTP method specific variants: get mapping, post mapping, put mapping, delete mapping, and patch mapping. These are method level annotations. Because this method is to serve a GET request, I'm going to use get mapping on this. And then I have to pass in the request URI or the path that this method would serve. So the request URI is post/1/comments, where 1 is the post ID, which is a path parameter. So it should be represented with a name inside of curly braces like this. The method parameter should also be annotated with @pathVariable annotation, giving the name of the path parameter, which is ID here, so that the value of the path parameter will be set to the method parameter, which is post ID. That's all there is to be done in terms of handling the request. But if I run the test at this point, it'll throw a null pointer exception, because the commit service here would be null. I want the framework to inject an instance of commit service here. For that, I'll have to do two things. First, this has to be annotated with @inject annotation. Or you could use the AutoWire annotation as well, which is Spring specific. But I prefer the @inject annotation. But it cannot be injected or auto-wired unless it is a type managed by Spring. So how do we make the commit service a Spring component? There is this @component annotation, which indicates that an annotated class is a component. Such classes are considered as candidates for auto-detection when using annotation-based configuration and class path scanning. Also, there are a few specializations of this annotation, such as @controller, @service, @repository. So I'm going to use @service annotation on the commit service class because it is a service. Following is an excerpt from Spring documentation, which is worth noting here. @component is a generic stereotype for any Spring managed component. @repository, @service, and @controller are specializations of @component for more specific use cases in the persistent, service, and presentation layers respectively. Therefore, you can annotate your component classes with @component, but by annotating them with @repository, @service, or @controller instead, your classes are more properly suited for processing by tools or associating with aspects. For example, these stereotype annotations make ideal targets for point cuts. @repository, @service, and @controller can also carry additional semantics in future releases of the Spring framework. Thus, if you are choosing between using @component or @service for your service layer, @service is clearly the better choice. Similarly, as stated earlier, @repository is already supported as a marker for automatic exception translation in your persistence layer. So now that I have annotated the commit service class with @service annotation, the commit repository dependency here should also be annotated with @inject. Now, if you are wondering how the commit repository interface will be injected here because interfaces are not instantiated, it is all done by the Spring Data Framework. All I have done to enable the functionality is that I have enabled auto-configuration, which in turn enables JPA repositories, because I have Spring Data JPA as a dependency in the class path. Spring will scan com.comment and all its subpackages for interfaces extending repository or one of its sub-interfaces. For each interface found, the infrastructure registers the persistence technology-specific factory bean to create the appropriate proxies that handle invocations of the query methods. Each bean is registered under a bean name that is derived from the interface name. For example, the comment repository will be registered as comment repository with a lowercase c at the beginning. So I don't have to do anything to the comment repository interface since it extends from CRUD repository, which in turn extends from repository interface. It is already eligible for auto detection and dependency injection. Okay, now that I have wired everything up, I will run the integration test once more. Now here we get another exception. It says, you are trying to execute a streaming query method without a surrounding transaction that keeps the connection open so that the stream can actually be consumed. Make sure the code consuming the stream uses @transactional or any other way of declaring a read-only transaction. So this is about the comment service which consumes the stream returned by the repository. I'll just extract this as a local variable so that it's more visible. There are two things which has to be done here. First one, although not complained were an exception yet, is to close the stream. This is very important because instead of fetching the list of comments all at once and then wrapping it in a stream, what happens is that Spring Data Framework leverages the JPA provider specific methods to perform the streaming, which is way more efficient. So it is mentioned in the Spring documentation that a stream potentially wraps underlying data store specific resources and must therefore be closed after usage. You can either manually close the stream by using the close method or by using a Java 7 try with resources block. So I'll use the try with resources block to consume the stream. Since the stream is auto-closable, it will be closed soon after it is consumed, regardless of success or failure. The second issue is what the exception is about, is that Spring expects a streaming query method to be executed within a read-only transaction. I haven't added any transactional semantics to this method, so before moving on with that, let's look at some basics of Spring Transaction Management. Now let's talk about transactions. This is a huge topic and beyond the scope of this course, but let's look at the essentials. So what happens when a method is transactional? Now, the method executes inside of a transaction. If anything goes wrong in the middle of the method execution, the transaction will be rolled back. Otherwise, it will be committed. So for example, let's say there were 100 comments in the database, and while this method is being executed, 30 of them were successfully streamed. But then something happens in the middle of it and it could not read from the database anymore. Since this method runs within a transaction, the whole method will fail instead of returning 30 comments, and that prevents us from getting an incomplete list of comments. Spring provides comprehensive transaction support, and here's a very simplified overview of how it works. Spring Framework's transaction support is enabled via AOP proxies. So the caller of the method invokes the proxy, not the target. And at this point, a transaction is created. Then the target method is invoked. And on the way back, either the transaction is committed or rolled back. How do we enable Spring's transaction management? Typically, it is enabled using @enable transaction management annotation, or it could be done via XML as well. But this is a Spring Boot application, so most of the configuration is done for me. Because I have Spring Data libraries in the class path, transaction management is enabled by the framework, so I don't have to do anything to enable transaction management. In order to apply transaction management, all you have to do is add the @transactional annotation. Now let's look at the annotation. The @transactional annotation is metadata that specifies an interface, class, or method must have transactional semantics. For example, start a brand new read-only transaction when this method is invoked, suspending any existing transaction. There are quite a few settings that can be applied to this annotation. This table from the documentation lists all of them. First, there is value, which specifies the transaction manager to be used. Then there is propagation. These are the transaction propagation behaviors defined by the propagation enum. Let's look at a couple of them. First, the default one, which is required. Supports a current transaction, creates a new one if none exists. If there is a transaction already started, then this method will execute within that. Otherwise, a new one will be created. Requires new. Creates a new transaction and suspend the current transaction if one exists. The next attribute I want to look at is read-only, which is a boolean. What happens when the read-only attribute is set to true? The default is false, by the way. Spring doesn't handle persistence, so it cannot define exactly what read-only should do. So this is just a hint to the provider, which in this case is Hibernate. According to the documentation, if using Hibernate as the JPA provider, when read-only flag is set to true, flash mode on the Hibernate session will be set to never, preventing any changes to data. Following is an excerpt from the Spring Data documentation which states this. It's definitely reasonable to use transactions for read-only queries, and we can mark them as such by setting the read-only flag. This will not, however, act as check that you do not trigger a manipulating query. Although some databases reject insert and update statements inside a read-only transaction. The read-only flag instead is propagated as hint to the underlying JDBC driver for performance optimizations. Furthermore, Spring will perform some optimizations on the underlying JPA provider. Example, when used with Hibernate, the flash mode is set to never when you configure a transaction as read-only, which causes Hibernate to skip dirty checks, a noticeable improvement on large objectories. Next is timeout, in which you can give the number of seconds before timeout. And then there is rollback for, which is an array of classes extending from throwable. These are the exceptions that must cause a rollback. The rest of the attributes are rollback for class name, no rollback for class name, for which you can take a look if you want to use them. Spring Transaction Management also supports the @transactional annotation from Java as a drop-in replacement for the @transactional annotation provided by Spring. But it lacks some of the settings available in the one from Spring, such as read-only and timeout, which are quite useful. So I would use the Spring's transactional annotation instead of the one from Java. So what happens under the hood when the @transactional annotation is added? When @transactional is present, Spring creates a proxy which will stand between the caller and the target, so that external invocations will always call the method on proxy, and then the proxy will invoke the actual method. But before the method invocation, it will create a transaction. Once the method execution finishes on the target, the transaction will be committed or rolled back. So that's that. Now the transactional annotation can be placed on interfaces, classes, or both class and interface methods. But Spring recommends that you only annotate concrete classes and methods of concrete classes with the @transactional annotation, as opposed to annotating interfaces. You certainly can place the @transactional annotation on an interface or an interface method, but this works only as you would expect it to if you are using interface-based proxies. The fact that Java annotations are not inherited from interfaces means that if you are using class-based proxies, that is proxy target class set to true or the weaving-based aspect mode set to aspect J, then the transaction settings are not recognized by the proxying and weaving infrastructure, and the object will not be wrapped in a transactional proxy, which would be decidedly bad. What does that mean? This is about the transaction configuration in Spring. When using XML-based configuration, there will be a line like the following in the config file, which would enable annotation-driven transaction management. These are the settings or the attributes which can be set on this tag. There is Transaction Manager, the mode, the proxy target class, and the order. Since we are using Java-based configuration, let's look at the annotation which would be used to provide the same configuration as above. So it is the @enable transaction management annotation. And it has these three optional elements: mode, order, and proxy target class. Regardless of the mode of configuration, that is either XML or Java-based configuration, so long as we have not specifically set these attributes, the default values apply. So let's look at each one. The proxy target class could be either true or false. The default value is false, in which case JDK interface-based proxies are created. If this attribute is set to true, then CGlib proxies will be used, which are class-based, and therefore any transactional annotations on interfaces will be ignored. Now the mode. There are two values that can be applied to the mode attribute: proxy and aspect J. The default value of mode attribute is proxy, which processes annotated beans to be proxied using Spring's AOP framework, which would proxy interfaces annotated with @transactional. But when the mode is set to aspect J, the interfaces annotated with @transactional will be ignored because the aspect that interprets @transactional annotations is the annotation transaction aspect. When using this aspect, you must annotate the implementation class and/or methods within that class, not the interface, if any, that the class implements. Aspect J follows Java's rule that annotations on interfaces are not inherited. So, as mentioned earlier, because this is a Spring Boot application, transaction management is enabled by the framework without me having to add the @enable transaction management annotation. So that means I'm using the default settings for proxy target class and mode. So as of now, I have no restrictions as to where to place the @transactional annotation, but it is safer to follow the recommendation in case those need to be changed. There are a couple of things to keep in mind when using proxy mode, which is the default setting. First, only external method calls will be transactional. Even though a method is marked with @transactional annotation, if it is called within another method of the same object, it will not have transactional behavior. The second one is that you should apply the @transactional annotation only to methods with public visibility. If you annotate protected, private, or package visible methods with the @transactional annotation, no error is raised, but the annotated method does not exhibit the configured transactional settings. So if you want transactional behavior in either self-invocations or non-public methods, consider the use of aspect J mode instead of proxy. To summarize, Spring recommends to only annotate concrete classes and methods of concrete classes with @transactional. When using default configuration settings, a method would be transactional only if it is called externally and if it is of public visibility. I highly recommend reading the documentation for Spring Transaction Management, as we cannot cover everything here. So I'll mark this method with @transactional annotation, with read-only attributes set to true. Notice here that there are two annotations, one from Java and other from Spring. I'm using the one from Spring. Going back to the integration test. Now I should be able to run the integration test without any issues. There we have it. I've got the first integration test passing. Let's take a look at the console. Because I've called and do print, the request and response should be printed in the log. So here's the request, the HTTP method, the request URI, no headers or body. And then here's the response. The status code is 200 as expected in the test. And the body is an empty list because there are no comments in the database. Now I'm going to write another test to check whether this API will return the requested resource, which is a list of comments. For this, I need to have some data in the database. The cool thing about Spring Boot is that we don't have to worry about database configuration for our testing. Because we added the H2 dependency at the beginning, it configures an in-memory database for us already for our testing purposes. All I have to do now is to preload it with my test data. There are a few ways to do this. You could inject the repository into the test class and save values directly through that. Use SQL or SQL group annotations to execute a set of SQL statements. These annotations can be used on both class and method levels. You could also create a script file in SRC Integration Test Resources folder and add all the insert statements there. It will be executed during application loading. I use a combination of the last two options. Before starting with the script file, let's take a look at the comment entity. I want the ID to be auto-generated, so I'll add that annotation. Then the commit message field is missing here, so let me add that as well. Now there should be a no argument constructor in order for this to be instantiated by the framework. So let's add that now. All set. Now I can add the script file. I'll create a new source folder in SRC Integration Test called Resources. And in that, I'll create a file named testdata.sql. So now I can add some records to the database using this file. Let me add a few insert statements here. If I had named this file import.sql, it will be picked up by Hibernate automatically to preload the database. But I haven't done that because I want more control over the test data. So I'll be using the annotations to load the script. Now on to the next test. What are we testing here? In this test, I want to make sure that I get all the elements of the comment. That is the ID, the post ID, and the comment text. So how do I do that? How do I assert or verify that I'm getting all these values in the response body? For this, I'm going to be using JSON path. JSON path makes it possible to traverse a JSON document, just like XPath does for an XML document. So here is the documentation at GitHub. You can find a lot of good examples here. Let's get on with the test. I'll add the SQL annotations first so that we get some data in the database. I'm using SQL group here to group the queries. I want to load the data right before this test, and for that I'll use the script file that I created and add it in the execution phase before test method. And then I also want to clean up after the test. For that, I'll simply use a delete statement in the after test method execution phase. I have copied this line from the previous test, and now I'll just run this so that you can see a proper response with some data. Okay, so here's the response body. I'll just copy this and paste it in a text file and format it so that we can see what we've got here. Okay, now it's time to add the JSON path expressions. First of all, I'm going to confirm that it is an array. So this is how you write that expression. Next, I'm going to fetch the first object of the array, and then I'm going to see if the ID has a value of 1. And then the post ID has a value of 1. And finally, the message has the string test comment 1. So let's run the test now. Okay, that's passing. So the next test that I want to write is to check whether we return status code 400 for invalid post ID in the request URL. Status is bad request. Let me change the post ID to an invalid one. So now this test is failing. It's returning status code 200 no matter what. To return status code 400, which is the bad request code, all you got to do is to add the response status annotation to the exception class and set the status code that you want to return when that exception is thrown. Okay, now we got it passing. You can see the status code 400 here as well in the response. So one more test I want here is to verify that when there are some records in the database, but there are no records for the post ID in the request URL. The response returns an empty array with status code 200. Most of this is covered in the first test, except that there are no records in the database in that case. Is an array. The post ID, I'm going to set it to 100. I'll be using the same SQL annotations here as well. No need to change the data as I'm not going to be querying them. I just want some data to be present in the database. And I also want to make sure that it's empty, so length is 0. Great, now I've got one endpoint working end-to-end. Again, we're going to start with the controller for the API. So this is the design of the REST API URLs. And we have completed the get URL so far. The next is the post, which allows us to add a comment to the database. So for this post request, we will be sending this JSON in the request body. The comment controller will receive it as a comment entity, and it should return the created comment. So in the HTTP response, we should get this JSON and the status code 201. Notice that this JSON has the comment ID, which is generated while saving the comment in the database. So let's get started with the unit test for this requirement. We want to add a new comment, and the method should return the created comment with ID, post ID, and the comment text. The comment that we pass into the method should pass some validations. That is, it should not have an ID, but it must have the comment text in it. So I'll create a new unit test method. I'll name this add new comment, and first I'm going to test the validation of the ID. So with ID set, throws invalid parameter exception. Since we're testing an exception, I'll add the expected attribute first. Now calling the method under test and pass in the comment which has an ID. I'll just extract this to a local variable and then set the ID to 1. And then I have to create this method in the commit controller class. Now I'll just run the test to make sure it fails. Yes, it fails because expected exception is not thrown. So now I'm going to implement the validation in the add comment method. So now I got that test passing. Let's move on to the next validation, which is the comment text. I'll just copy this test and rename it. I can just pass in a new comment here with no values set. So I'll run the test first. It is failing due to the same reason as before. So now I'll implement the validation. Here I'll first check if the message is null and then also check if it is empty. Run the test again. Now it has passed. In the next test, I'm going to check whether it returns a comment with ID when a valid comment is passed in. So with valid comment, returns comment with ID. For this, I'm writing the assert first. For the actual, I'm going to call the method and get the ID. So I'll create a local variable for the comment because I need to set the comment message in it. I'll create a matcher with is greater than 0 to compare the ID with. Now before running the test, I have to get it to compile. The method return value should be changed from void to comment. And then I can run the test. So it's failing due to an assertion error as expected, and I'll add the implementation now. The quickest way to get this test passing is to set the ID before returning the comment. It's dodgy, I know, but I'll come back to correct this in a second. So I'll run all the tests again and make sure they all pass. Now back to the implementation. We got to do some refactoring here. It is definitely not the responsibility of the controller to set the ID. The controller should only delegate to the service after validation. So I'm going to move this to the service. So for that, I'm going to create a test in the service test class. A very similar test to the last test in controller. Pass in a valid comment and it should return the created comment with the ID. So I'll create the method in commit service to get this to compile. And then run the test. So it fails due to a null pointer exception. So I'll return the comment instead of null and run this again. Now the assertion is failing. Now I'll go back to the implementation. I'll do the same dodgy thing here just so we get the test passing. And then looking at the implementation, is it the responsibility of the service to set the ID of the comment? No, because it is auto-generated while being saved. So all we can do here is to pass this on to the repository for saving in the database. So now if I run this test again, it's failing due to a null pointer exception. That's because I'm calling getID on a null. I've set up a mock for comment repository, but it returns null when the save method is called on it. A mock has to be told what to do when each of its methods are called. So that means I have to tell comment repository mock to return a comment when the save method is called with this comment object. So now I got it passing, and the implementation is looking clean as well. Let's go back to the comment controller to fix the dodgy implementation. I'll run all the tests again to make sure they all pass before doing any modifications. So that's all good. At this point, the controller should delegate to the service. Run the test once more. So we're getting a null pointer again because the mock hasn't been set up for the new method. So I'll do that real quick. Now it's passing. On to the next test. The returned command should have the post ID set in it. I'll just copy this test and modify the method name. And then change the actual to post ID instead of ID. Let's run the test now. So it's failing as expected. Assertion error, expected is 1 but was 0. As you can see, this is the JSON that comes in the request, which only has the comment text. So where is the post ID? How do we get hold of the post ID? Well, the post ID comes in the request URL as a path variable. So we need to add it as a parameter to the method. And then before passing the comment to the service, I'm going to set the post ID on the comment. And now I have to update the method calls in all the tests. Let's run the test. It's still failing. That's because during the test, the add comment method is returning the comment which is provided by the mock. I have set up the mock so that it returns a different comment object to the one that's passed into it. What I'm going to do now is to set up the mock to return the same comment that's passed into it by using then answer instead of then return. By the way, I have given a lot of examples in this Mockito post, so if you are new to Mockito, check it out. It covers almost everything you need to write some decent unit tests. So here I'm basically getting hold of the argument that comes to the method and returning it as it is. Okay, got it passing as well. The next one is to test the comment message. So I'll copy this test and rename it. Then I also need to change the asset as well. So I have it already passing without having to do anything in the implementation. It kind of suggests that this test is not needed, but I'll let it be for the moment. Now I also want to make sure that we validate the post ID as well. So I'll add another test for that. Expected invalid parameter exception. Let's run the test. No failing test. Well, we're missing one important condition here. The valid comment. So I'll set the comment message to make it valid. Now the test is failing. And I can add the validation to the implementation. Okay, all tests are passing now. Looking at the service test again, I want to make sure that the comment has a valid post ID before it is saved. So I'll first write a test for that. The test has failed, so now I can add the validation in the comment service. Now that test has passed, but the other one is failing due to the validation that we added just now. I should send a valid comment, so I'll set the post ID and the comment message as well. Going back to the comment controller, I think we can extract this validation bit to a separate method. Let me do that real quick and then let's run the tests again. All good. Now it's time to move on to integration testing. So here I am in the integration test class. I'm going to list down all the integration tests that I want to write here. I want to test that it returns the correct response status code, which is 201 for created, when a valid request is sent. Then it should return status code 400 when the ID exists in the request body. And it should also return status code 400 when the post ID is invalid in the request URL. And finally, I want to test whether it returns a JSON with ID, post ID, and the comment message in the response when a valid request is sent. So I'll start by copying this test and then I'm going to rename it to add comments for a valid request status is created. So now I have to change the request method from get to post. The URL is the same. Now this post request has a request body. So I'll set the request body using the content method and I'll pass in the JSON that I want to send in the request body to the content method as a string. So this is the JSON that we're going to send in the request. And then I'm going to make it into a single line and copy and paste it in here within double quotations, so all the double quotes inside will automatically get escaped. The status expected here is created. So now all done with the test, I can run it. I'm going to run all of the tests in this class. The test is failing because the expected status code is 201, but the response returned with a status code 405, which is method not allowed. And if you look at the console, here's the exception. It is an HTTP method not supported exception. That means the controller or the application does not serve a post request for that URL. Or in other words, there is no method serving a post request in the controller. We only have a get request mapping annotation here, so let's add the correct annotation to the method. The request URL is post/id/comments. And this ID is the post ID, which is the path variable here. And if you notice here, I've added the request body annotation to the comment parameter. So let's run the tests again. Again, it's failing. Now it's returning a 415 status code, which is used for unsupported media type. Let's look at the console. So here's the post request, the request URL and the JSON request body, and the exception is HTTP media type not supported exception. So we're getting this exception basically because we are not setting the content type in the request headers when sending the request. So let's do that in the test. Here I'm going to set the content type, set it to media type application JSON. I'll run the test again. This time I'm going to run only this test so it's easier to find the request and the response in the console. Again, it's failing due to an assertion error. The status expected was 201 but was 200, meaning OK. To set the correct status code on this method, all you have to do is add the response status annotation and set the HTTP status code to create it, just like we did in the exception class. So again, I'll run this test. Now it has passed. So the second test that I'm going to write is to check whether it returns status code 400 if the commit ID was sent in the request body. I'll copy the previous test and rename it to invalid request with commit ID status 400. And I'm going to modify the JSON to include the ID in the request body. ID is 1 and the message I'm going to set it to test commit 2. Change the expected status to bad request. I'll run the test. It passes because I've already added this response status annotation to the exception class, and whenever it is thrown from the commit controller, the response status code is set to 400. Now the third one is to test whether it returns the status code 400 if the post ID is invalid. Again, I'll copy this test and then rename the method to invalid request with invalid post ID returned status 400. So now I'm going to set the post ID to an invalid value. And then the commit message, I'm going to set it to test commit 3. I'm setting these commit messages different in different tests so that it's easier to identify in the console. Now I can run this test. So that test has passed as well. And finally, I'm going to test whether it returns a JSON with ID, post ID, and the commit message in the response when a valid request is sent. For that, I'm going to again copy one of the previous tests and rename. A valid request returns created comment with ID, post ID, and message. And expect I'm going to get the ID from the JSON of the response. So the JSON path expression for that is $.id and the matcher is 1. So the second one is post ID and that's going to be whatever we sent in the request URL. I'm going to set it to 4 so that it's more clear, and then the message. So that's all for that test and I'm going to run it now. So here's a request and the request URL. This is the request body and then we have the response body with ID, post ID and the message. So coming back to this test, this ID is not something that we send in the request and not something that we always have control in the test. So what I'm going to do is to set this to something which is more predictable. I'll change this matcher to greater than 0. Ideally, we shouldn't have anything in the database, so it shouldn't be a problem, but just to be on the safe side. So that's all the integration tests that I had planned for this. And now I'm going to run all of the tests in this Comment API test class. Great, all tests are passing. So far, we've been running integration tests, but does this really work outside of tests? Before moving on to the next one, which is delete, I just want to show you how this works end to end. First of all, I'll start the application in Eclipse. So the application has successfully started and it's available on port 8080. I'll just open up a browser window and send a request to localhost 8080 posts/1/commits just to see what we get. Great, we get an empty list. That's because there is no data in the database. Now we have implemented the post, we can add some data. For that, I'm going to be using Postman. So here I've opened up Postman and I'll change the method to post. Then create the request body. So that's all we need in the request body. I'll send this request. Here we have a response with the created comment. Okay, let's see if it comes through the browser as well. That way we know for sure that the comment has been added to the database. It is coming through, which is great. Now let's see how to delete a comment. Again, we're going to start with the API. We have get and post already implemented and working end to end. So next up is the delete. The request looks like this: comments/ID, which is the ID of the comment which needs to be deleted. We want the commit controller to accept and process this request, and then send back the HTTP status code 204 in the response. So let's start with the unit tests. I'm going to open up the commit controller test class. And at the end, I'm going to list down all the unit tests that I want to write for the delete functionality. So first, I'm going to write a test to validate the commit ID. It should throw exception for invalid commit ID. I want this method to throw an exception if the commit does not exist in the database. And for now, let's start with these two unit tests. So for the first test, I can actually copy this one over here. The exception is invalid parameter exception. So this is going to be delete comment. Invalid comment ID throws invalid parameter exception. The method name is going to be delete comment. And I should pass in the comment ID as well. So passing -1, which would be invalid. So now in order to make this compile, I have to create this method in the comment controller class. And now I'm going to run the test. So here we have a failing test. I'm going to implement this validation in the comment controller. So if I less than 1 throws a new invalid parameter exception. Okay, that's passing. Now, one thing that I want to do here is to rename this to comment ID because this is the ID of the comment that we're passing into this method. Okay, let's run the test once again. Good, it's still passing. I'm going back to the test class and going to write the next test, next validation, which is to throw an exception if the commit does not exist in the database. So for that, again, I'll copy this test. In here, I want a not found exception. So I'm going to rename this method first. When comment does not exist, throws not found exception. And now I'll create this exception in the src main Java folder. Superclass should be runtime exception. So now I want to pass in a valid comment ID to this method. And if this comment does not exist in the database, I want it to throw a not found exception. So first, let's run this test. Okay, it's failing. And now I'm going to add the implementation. So how do I do that? First of all, figuring out whether there exists a comment for this ID or not is not the responsibility of the controller, but of the service. So it has to be delegated to service. So I'm going to set up the comment service mock that we have here. Do throw not found exception when what? Well, that's when the delete method is called on this mock. But the problem here is that there is no delete method in the comment service. So I'll have to implement it in the service and then come back to this. But for now, I don't want to leave this a failing test. So what I'm going to do here is to throw the exception from in here so that I get this test passing. Great. Now, in the comment service test class, I'm writing a very similar test. Copy this and rename to delete comment. When comment does not exist, throws not found exception. And comment service, delete comment, and pass in the comment ID. So, in order for this to compile, I have to create this method in the comment service class. Okay, now run the test. It's failing at the implementation. Now, there are two approaches to delete something from a database. You could do a soft delete, also known as a logical delete. Then there is hard delete, also known as physical delete. Soft delete can be implemented by marking the entity or the record as inactive. This is also known as flagging. When you do this, there's a bit of additional work on the other side. That is, you should make sure to filter out the inactive records and only retrieve the active ones. But the advantage is that you get to keep the history. On the other hand, if you do a hard delete, it erases the record from the database permanently. You don't have extra work on retrieval, but you lose the history. Depending on the requirement, you can choose the best approach. So I chose to delete permanently because I don't want to keep the history of all unwanted comments. So the implementation is simpler. What I'm going to do here is first check if the comment exists. Exists by ID, else throw not found exception. Run the test. It's failing. Oh, here's a side effect of copy-paste. Fix that and run the test again. Now it's passing. Now I want to verify whether the service calls the delete method on the repository. And for that, I'm writing another test. Copy this one here and rename. Now I'm going to set up the mock. When comment repository exists by ID, then return true. And then call the method under test. Verify that the comment repository delete by ID method was called with a value of 1. Run the test. It has failed. Wanted but not invoked. So I'll add the implementation now. Run the test. Okay, it has passed. Let me rename this to comment ID and run the tests again. Now, going back to the comment controller, instead of throwing the exception from here, I'll call the delete method. Run the test. It fails. Now I'll set up the mock to throw the exception. Run the test again. Now it has passed. The implementation looks good, as well as the test class. That's all the tests that I wanted to write for this delete functionality. So let's move on to integration testing. Now, let me open up the comment API test class where I have all the integration tests of this API. First of all, I'll run all the existing tests, just to make sure that I don't have any failing tests before starting. Good, all tests are passing. So for the delete functionality, I would write the following integration tests. The response code should be 204 for a valid request. Actually delete the comment from the database, and then return response code 404 if the comment with the particular ID does not exist. I'll start with the first one, just checking the response code. Delete comment for valid request returns response code 204. Now I'm using MVC to perform a delete with the URL comments/1 and expect status is no content. I also want to print the request and response as well. Throws exception. Now there should be some comments in the database for it to be deleted. So for that, I'm using the SQL annotation to preload the database. The execution phase should be before test method, and I'm going to execute this statement to insert a comment into the database. I also want to make sure the database is clean after this test. So I'm going to move this into an SQL group and then add another SQL statement to delete the comment. This should be executed after test method. Run the test. It's failing because I haven't added the necessary annotations to expose this API method. So I'll add the delete mapping annotation here, and also the path variable annotation to this parameter so that the comment ID will be passed into the method. So run the test again. Again, it's failing. Status expected is 204 but was 200. That means we're getting an OK response, but what we want is a 204, which is no content. So let me add the annotation. I'll run the test again. OK, now it passes. Next test is to check whether the comment is actually deleted from the database. I'll copy this test and rename it. I'll remove the status check because it's already been done in the previous test. For this test, first I'll send a GET request to get all the comments and make sure that there is a comment in which the ID is 1. So this JSON path expression is to get the length of the array. It should be 1 because I have added just one record in the database. And then this JSON path expression is to get the ID of the first element, which is the 0th element of the array, and make sure it's 1. And then print. Next, I'll send the delete request to delete the comment with ID 1. And then I want to send another GET request. This time it is to make sure that I'm not getting any comments back because that record previously retrieved by the GET request should be deleted now. So the length should be 0. Run the test. OK, it passes. So for the final test, I'll copy this test and rename to when comment does not exist, returns response 404. And I want to make sure that there are no comments in the database this time. So I'll add this SQL annotation. Status expected is not found. And then I'm going to change the execution phase from after test method to before test method. Run the test. It throws the exception, but the test is failing because the expected status code is not returned. So now I'm setting the response status code in the not found exception class. Response status, HTTP status not found. Run the test. Great. It's passing now and returning 404 status code. So that's all the integration tests that I had planned for this delete functionality. And finally, I'll run all the tests in this API. Great, all tests are passing now. So far, I've been running integration tests. Now it's time to run the application. Normally, when you build a web application, it has to be packaged to a WAR file and then deployed in a server in order to run the application. Here I have built a web application with Spring Boot. And the convenience of it is that it doesn't have to be packaged to a WAR file or deployed in an external server in order to run the application. But that doesn't mean that you cannot do a typical deployment with it. There are quite a few options or ways of running the application. Each has its uses and benefits. We'll explore all of them one by one. First, let's look at the easiest and the quickest option. It is to run the application using Gradle. As I mentioned while creating the build file, there's a boot run task in the Spring Boot plugin which allows us to run the application without having to package it. So all I have to do is to run the task on command line. So Gradle W, boot run. As you can see, the application is starting. Once it's started, I'll send a couple of requests using Postman to see if it's working properly. Now let's first send a GET request. It's returning an empty list. That's because there is nothing in the database. Now I'll send a POST request with the commit message test commit boot run. Let's see if it comes through the GET request. Yes, it's working perfectly. Now the delete. Now it sends back the correct response code. And the comment has been deleted. Perfect. Now let's try the second option. That is to run the application as an executable jar. For this, you don't have to do anything other than to build the application, which will produce an executable jar file. Creating the executable jar file is done by the boot jar task of the Spring Boot Gradle plugin. But we don't have to run this explicitly because the assemble task is automatically configured to depend upon the boot jar task, so running assemble or build will also run the boot jar task. And then execute the jar file in command line as you would run any other jar file. So I'll change directory to build libs directory and run java jar and the application jar file. The application is starting up. Okay, now I'll send some requests using Postman to see if it's working. So this is a collection of requests that I have saved earlier and I've written some tests as well. Okay, looks good. All tests have passed. Even if I just send a request through the browser, it should work. So let's see. Yes, it's working perfectly. Now let's try the next option that we have. It is to create an executable WAR file. For this, we need to first work on the commit application class. It already extends from the Spring Boot Servlet Initializer. So I'll override the configure method like so. This is to initialize the servlet context. Next, I'll add the WAR plugin to the build file. Now I'll run a Gradle build to package this to an executable WAR. So here's the WAR file. Let's run this and see if it works fine. Java jar comments.war. Application is starting. I'll use the same set of requests to test this one as well. Great, all of them have passed. Last but not least, the old-fashioned WAR deployment to an external server. For this, I'll have to exclude the embedded Tomcat dependency so that it would not conflict with the external server's own classes. The Spring Boot Starter Tomcat dependency is included by the Spring Boot Starter Web dependency that I added to the build file. So to move it out of the implementation dependencies, I'll add it as a provided runtime dependency. This will move the libraries to webinf lib provided directory inside the WAR file. If I build the project now, I'll package the application to a WAR file which can be deployed in an external container, such as Wildfly or Tomcat. But what if I want to reduce the size of the WAR file and get rid of the embedded server dependencies completely from the WAR file? If I deploy this in an external server, those dependencies are of no use anyway. So to do that, what we should do is to create a normal WAR file using the original WAR plugin of Gradle. What happened earlier is that even though I added the WAR plugin to the project, the Spring Boot Gradle plugin overrides it by the boot WAR task. To execute the normal WAR task, it should be enabled. So WAR enable true. And I also want to generate the executable WAR file alongside with this so that I can compare the two. So in order to do that, I'll configure the boot WAR task to add a classifier boot to the WAR file generated by it. Now when I build the application, I'll have two WAR files created. One is the normal WAR file without the embedded server, and the other is the executable WAR file. So here are the two WAR files. As you can see, the normal WAR file is smaller in size than the executable WAR file. Now I'll deploy this WAR file in the Wildfly server, copy the WAR into the deployments folder, and start the server. So I'll run the same tests on this one as well. Okay. I have installed MySQL Server here, and now I'm starting the server. Log into the MySQL Server. First, let's see what databases are already present. Show databases. Okay, so this is what we have at the moment. Now I want to create a new schema in here for the comment application to connect to. I'll call it Comments app. Okay, that's all I want to do in the database. Now on to the application. You have to do only two things in order to connect this application to MySQL Server instead of H2. The first is to add the MySQL connector dependency to the project. So I'll add it here as a runtime only dependency. The next step is to let Spring Boot know that it should connect to MySQL instead of the embedded database. I'm going to do it via an application properties file. What is an application properties file? It is one of many ways that Spring Boot lets you externalize configuration. A Spring Boot application loads properties from an application.properties file placed in the class path. This is where we should provide the database connection URL. In addition to the connection URL, I will also add the Spring JPA Hibernate DDL Auto and set it to create for the first run and then change it to update later. Setting it to create will create the tables for the entities in the database, which makes it easier to get started. But after that, we only need to update if there are any changes to the entities. Then I also need to provide the username and password to the database as well. That's all we have to do. Now I'll run the application and check. The table comment has been created, but there's no data in it yet. I'll send some post requests. Now let's check the table. Okay, it's saving all the records properly. Now that we have moved from H2 to MySQL, let's see if the integration tests are still working. As you would guess, they fail because there's no database connection. So how do we use MySQL and still use H2 for testing purposes? Well, it's really simple. All you have to do is to overwrite the application properties that we just added. For that, I'll add another application properties file inside of SRC integration tests resources. This is just a blank file. You don't have to have anything in here. And this file will overwrite the one we added earlier. You can find out more about the precedents in the documentation. So now let's run the integration tests to make sure they work. Great, that's working as expected.